One area of integration that is examined in our Leaving Cert is the area between the two lines. So we're going to have, and it doesn't matter, straight, bend, doesn't matter. The point is that I'm going to have one function, I'm going to have a second function, and we are looking for area in between those two lines. So what we have here, the diagram shows the graph of the function h and k. And we can see that function h, that's the one here, and then we have function k, and that's that line here. Now, what they are saying here, not that. How do I understand this description? They are saying not that when x is equal to the value of function h, meaning y, is the same in function k when x equal to. So they are basically saying y is equal y for both of those functions when x is 2. And we can see that here, x is equal to here, and the corresponding value of y, that point belongs to the 2 function. And the same here. They are saying when x is 8, therefore the y in function h is the same as y in function k, because we can see that that's where it is. Use the integration to find the area enclosed between the graphs h and k from 2 to 8, so within that interval. Okay, so how do we calculate the area between the two lines? So we integrating in the interval b and a, b being the higher and a being the lower, and we consider which y is the high value of y minus the function that the y values are lower. Now, what do I mean by that? Let me explain. So if we pick, let's just pick a number. So if we pick, let's say, a value of x here, it doesn't matter what that value is. For this value of x, if I go across, that's going to be y for the function k. And then again, if I go a little bit above that to find the next function, so this will be the value of y for function h. So we can see that k at every point here is going to have the lower value of y, while h for every point of x is going to have the higher value of y. So here I'm going to have function k, and here I'm going to have function h. So once we do that, therefore we're going to have our function created that we're going to integrate. We're going to say that this is the function that we're going to integrate. In the next step, we are integrating. What does that mean? That means that we are applying a formula to our function here. And then in the next stage, we are finding the value. So that means we take our function, we replace x with the higher interval minus, and again our function that is integrated, and we replace x with lower interval. Okay, let's apply that knowledge here. So first our interval, they told us 8 and 2, so b is always higher, a is always lower. So first let's deal with our function. So function h is minus a half x to the power of 2 plus 4x plus 1. And the good advice here is to actually put that in the bracket because of that minus here. And let's put our second function. So our second function is 9 minus x. So first, let's deal with that, taking it away. So we are saying 8, 2, and let's remove that minus, meaning changing the signs here. So minus a half x to the power of 2 plus 4x plus 1. First one just copy, and then the next one we're changing the sign. Minus 9 plus x. So we can simplify that a little bit further. We have minus a half x to the power of 2. Then we have 4x plus x. Therefore, we have 5x together. And plus 1 minus 9, that's minus 8. So now that we have simplified our function, we are saying, okay, we're going to integrate, meaning apply the formulas. And how do we do that? Each element, isn't it? We're going to apply that separate. That's a very simple integration. if we look at our table, that's the very first formula we have in the table here. So when we have x to the power of n, when we are integrating, what happens first, we have a fraction x n plus 1, and that will be divided n plus 1. What happens if there is a number that stands here? It crosses over, isn't it? Okay, so let's apply that. That means minus a half will cross over, multiply, and then our fraction x, so 2 is the power plus 1, and then divided by 2 plus 1, plus, and again, 5 will cross over, x, and the power here is what? 1, so 1 plus 1 divided again by 1 plus 1. And what happens here when we don't have x beside it? We know that originally, don't forget, integration is the reversal of differentiation, of creating a derivative. There was x, and that's how it became just 8. And let's not forget about our interval 8 and 2. So now we can simplify it, or we can jump into directly solving in the values. But okay, let's simplify it a little bit. A half multiply x to the power of 3 over 3 plus 5 x to the power of what? 2 over 2, and then minus 8x. And still we are saying within that interval. So now we are taking this function and we are replacing x with the higher interval. And then 5 multiply instead of x, 8 to the power of 2 over 2. That's a multiplication sign here. Minus 8 multiplied by 8. So that's one part. Minus, and then the second part, again that same function, but this time we are replacing x with the lower interval. In this case, that should be power of 3, with a lower interval in our case, that is 2, plus 5 multiply, and again 2 to the power of 2 over 2 minus 8 multiplied by 2. And we put all of that in our calculator, we press equal, and we get that that value is 18. So that is the area enclosed between those two lines.